All right, good afternoon, everyone. My name's Chris Hughes. I'm from Cargill Ocean Transportation. I'm part of the Czech project. And I'm going to talk about wind wings, which was is basically a sail technology that part of the Czech project that we've installed on board one of the bulk carriers. So we've seen a lot of presentations today, very much about some of the awesome analysis and calculations and other kind of tests that we've done. I'm going to talk about specifically the testing of the wing sails within the project. So what are the wing sails? It's nothing new. The idea of putting sails on ships, it's been done before. We didn't come up with that idea, but what we have got here is a idea of sails reimagined. Okay, these are kind of rigid wing sails. And you can see here, as part of the project, we installed 2 of these sails. One of them was funded through the Czech project. The other sail was funded by ourselves, Cargill, together with the ship owner, Mitsubishi Corporation. And we installed them on this bulk carrier, which is a Kamsarmax, 82,000 ton deadweight bulk carrier, last year. So I'm going to kind of run through what the sails are and a bit of the journey so far. So basically, as you saw there, these are kind of rigid wings. They're like aircraft wings. Okay, so they have a steel mast or kind of spine up the middle, which is shown there in yellow, which is kind of a steel box structure. And then the rest of the parts, the white parts, are composite fairings that shaped like a wing, like an aerofoil section. There's what we call 3 elements. So there's a main wing with a leading element, a flap at the front, and a trailing element, which is a flap at the back. They're about 37.5 meters wingspan, so the top of the sail is about 45 meters above the deck. These things are huge. When you see them in reality, they're really big, and they're 20 meters wide as well. So these are big units. So how do they work? Because they're that tall, they'd be too tall to go under some of the bridges and fit under some of the kind of the port loading and unloading infrastructure that we need to deal with. So they're designed to raise and lower, like you can see here. So the concept is that we keep them up when we're at sea. We put them down in port or approaching into port for pilotage and departing from the ports. And we also fold them down above about 50 knots. So they're designed to operate up to 50 knots of wind. They are approved by class to stay up to 100 knots of wind in kind of an extreme case and to survive that. So when they're down, you can see they're quite large units, so we need to be able to kind of rotate them and move them so they don't get in the way of the hatches for loading and unloading the vessel. So when they're down, they have 4 different positions, 2 different positions for loading. That gives us some flexibility to deal with different ports and different cranes. One other just kind of standard condition for when we fold it down at sea in a storm. And a 4th one where it's suitable for going through canals, so it doesn't hang over the side of the vessel to comply with the canal regulations. So when they're up and being used, they're fully automated. So the crew on board, the idea is to try and make it as simple as possible. So literally you press a button when they want to put them up, press a button when you want to put them down, and while they're operating, they are automatically adjusting. So what we have, anemometers, wind sensors on board the vessel that is measuring the wind at any given time, and the computer control software for the system is adjusting the rotation of the sail to the wind and then adjusting the flaps as well, which optimize the lift and the drag that you get out of the sails for any given condition. We also monitor the rudder angle on the vessel as well, so that if you're getting too much power from the sails and you need too much rudder to keep you going straight, there's a safety concern about that, so then the sails can also depower to meet those safety requirements. So that's how they work. So the installation, so we started off at Czech. There was a whole lot of work being done by lots of people in this room beforehand to design to build the sails. The sails themselves were constructed in China by Manta. And then in June through to July, beginning of August in last year, we installed the sails on board the vessel in a place called Costco shipyard in Shanghai. So that was kind of done in 4 stages. So first we had some prefabrication of steel. So we need to make some modifications to the ship to be able to take the sail. So we prefabricated some steel before the ship arrived. Ship arrives, then we had a period where we're cutting holes in the vessel to get ready for the sails, building the foundations. The next step is installation of the sails. So you can see here the sails were delivered from the factory down the river on a barge and then lifted on board the vessel. And then the last part of it is commissioning and testing of the sails. The installation went pretty smoothly, no major problems, although there were some pretty nervous kind of moments. We had 2 typhoons, one just before the vessel was finished. Luckily it changed direction and missed Shanghai, and we had another one just when we went on sea trials. So we want some wind for sea trials for these things. You don't want too much. It was pretty scary for a while, but luckily the typhoon changed direction and we ended up with some really nice wind, actually, just the right amount for kind of testing on sea trials. So we got lucky there. Yeah, this is these are the hydraulic rams that we use to raise and lower the vessels, and I love this video because these things are just huge. So an interesting thing about this technology, it's everything in the sails is pretty much what you have on board ships already. Hydraulic systems, electrical kind of control automation systems, steel work, hydraulics, nothing that different, but it's just we're putting it together in a way that it obviously is visually very different, and some of them, like these hydraulic cylinders, are just huge. So after the installation, what we had planned in Czech was a 7-month, what we called kind of the demo voyages, so a period where we could test and learn as much as we could from this installation. That's kind of one of the things we really want to do in Czech is learn as much as we could. And there's a few different kind of areas that we wanted to learn. Functionality, so particularly on the first voyage from China, Shanghai there, over to Brazil, the one in red you can see there. What we focused on that voyage is really testing the functionality. Do the sails kind of work as we think they should? They did, which was really good. And also training the crew. So we had 2 engineers the whole way to Brazil, which is about 55 days, one from BAR and one from Manta Marine, on board the whole way to kind of run these tests, but also kind of spend some time with the crew to get them comfortable and confident in these sails, get them really happy to be operating them by themselves. Then after that, we focused on kind of learning some other things, operational experience, how we as an operator ship's going to operate something with these massive sails. You know, what does that mean? What's different? Performance tests, we wanted to know. We had some really good predictions of how much fuel and how much CO2 these sails are going to save. We wanted to try and measure and quantify that. And also the port interfaces. I'll talk about that in a bit. So, performance testing, like I said, do the sails save as much as what we think they should? The approach we took, I think, is quite important. We didn't want to just kind of measure how much fuel we saved on these voyages, because that doesn't tell us much. We could do the same voyage 10 times over, and every voyage would be different. Sometimes we'd save a lot of fuel because we got some really good wind. Other ones we might save not much. So just measuring what happened statistically isn't a very good way of doing it. So the approach we wanted to take is that BAR, who designed the sails and kind of the smart people behind all of this, had already created some simulation models that we'd been using in Czech. So what we wanted to do is validate and say, are these models correct? And the way that we chose to do that is to run what we call kind of on and off tests. Very similar to kind of what Arno showed before with the Silverstream system. So We literally run with the sails turned off, the kind of the red period there, and we measure at a constant RPM speed, power, fuel consumption, all of these type of things. And then we put the sails on, and the ship speeds up. At the same time that ship speeds up, the power in the engine comes down as well. Those two happen together because the propeller characteristics, and we measure the difference. And then we say, okay, so in this case, in the test I'm showing here, saved just under 32% in energy per nautical mile. How does that compare to the model? And we repeat these tests over and over again, and what we found actually is, to BAR's credit, that their model was very good. It's not easy to do this accurately, so we're still doing more and more of these tests, but I think one of the things we're really happy about is they're doing what we were hoping they would do and what BAR said they'd do. Port interfaces is another kind of really important part of the learning. So you can see these are big structures. We can't just assume that they will be okay for every terminal, every berth, every port that we go to. We did a lot of homework beforehand to talk to more than 250 ports to ask them, this is what the vessel looks like. Can we come to your berth? Is it okay? Is it going to work? Have you got any concerns? So we did a lot of homework, but there's nothing beats real experience. So that was one of the other things we've been really kind of focused on this. We kind of started, in terms of wind wings and future scale up, we started with probably the hardest vessel you could take. If you put these sails on a tanker or a lot of other vessels, the ports, they're all going to accept it. It's not going to be a problem. Bigger bulk carriers are generally easier. Smaller bulk carriers are easier. We picked, I think by accident rather than design, probably one of the hardest ships to get this to work on. But that's good. Let's start with the hard stuff and then it just gets easier. So far the ship has been to, I think it's 6 different ports total. It's been to a few multiple times. It's done about 9 port calls so far. What's really good is that each one of those has gone successfully. We haven't had any big problems. And importantly, each of those terminals is happy to have the ship to come back. I think that's been really good. We've still got some work on getting some other kind of ports and terminals to accept the vessel, but that's been a real positive. And one other big positive, we have one port in particular is giving us priority berthing. So this is a port that generally has a lot of congestion, a lot of big queues, and what they want to do is promote green shipping, reward people for taking a risk and being an early mover, and they allow this vessel to jump the queue, which is great for us because we get to jump the queue. It helps to give us a return on the investment and the risk we're taking for this. And so I think this is a really good sign. And for anyone that's in Synergy here and anyone from any of the ports, I think it's a great idea. Hopefully more people do it. And you can see one of the challenges around the ports is every terminal, every berth is different. You can't just say, okay, I design it for this and I know it'll work. Everywhere you go is different. The other thing I mentioned before that we really wanted to kind of learn about was operational experience. So from the shore side, from us as a vessel operator, like I said before, how do we operate this vessel? What's different? What do we need to think about? How do we operate this ship that we get the maximum out of the wings? I think one thing we've learnt about is if you're smart about how you operate the ship, you get more out of them. If you just kind of take them out of the box, plonk them on the ship and say, I'm going to operate the ship the same way I always have, you don't get as much benefit. So we've put a lot of effort into and we've learnt a lot about how to do that. The other part of operational experience that we've been kind of really interested in, we wanted to test, was the ship side of it, the human factors. How do the crew go with this? This is really different. When I went to the installation, I asked the crew on board, has anyone here sailed and, sailed sailing boats? And they all looked at me. Of course we haven't. I went, okay, this is going to be interesting. How are they going to go? But it's been really positive. I'll just, in case you get bored listening, get that video going. No. Yeah, it's been really positive, and I think partly we've been really lucky with the guys on board because they're super engaged in it. They really want to be part of this. They're proud to be involved in a new technology like this. They're very curious. So when they get challenges to come with this new technology, they're open, they're finding solutions, ways to work with it rather than waiting for someone what to do. So I think that's been a real positive. They say one thing, when they get kind of in congested waters, often they've got the sails up, they'll get calls from other ships on the VHF, literally calling them up and saying, I can see these huge white things on you, what cargo are you carrying? And the captain actually said they're kind of like the guys anyone on the bridge is kind of almost fighting to get on the VHF because they want to kind of go back and say, no, it's not cargo, these are sails, And so they're super proud to be kind of involved in it, and I think that's been really positive. I think the other things is we've found from there was questions around navigational aspects and training and competency of the crew for navigating a vessel with sails. It's still early days, but what we've seen so far is very positive, I think. The officers of the watch have adapted really quickly to this. We have a blind spot here. We have a camera system that is approved to cover that blind spot, but I think that's been a real positive. So I think in summary, we've done the vessel kind of 9 months in installation so far. I think you've seen there we've learnt a lot. I think we've achieved a lot of the goals that we wanted out of this in Czech, so I'm really happy about that. But I think really this is kind of step one in the journey. We've still got a lot more that we are learning, can learn, and we're super excited to be working together with kind of BAR to not stop at the end of the check, but keep learning, feed that into future generations of this design so that we're ready to scale up these technologies in the future. Thanks. That was where we are now. So John Cooper, who's the CEO of BAR, the smart guys that put this together, is going to talk a bit about the journey from here. And then I think we can have some questions, yeah? I'm hoping there's going to be some questions, particularly from you guys up there. Yeah.
Thanks, Chris. It's always great to hear someone else talk about the technology that we developed together. This is Bartek designed and built, but actually, I don't know if you showed the video. Sorry, I was out doing something else. But literally, I think I said on that video, Cargill phoned and asked us to design and invent some wind propulsion, and that's actually what they did do. It happened to be with the European Union and Czech, but massive thanks to Chris and everybody at Cargill and everybody at Czech for making this happen. I'm standing here as CEO of Bartek, which used to be a tiny business. We were arrogant and thought we could design anything we wanted, but we hadn't designed a huge amount at the time, and Czech and the EU provided us with an incredible opportunity. Not only to get some funding, but to actually try and build around the consortium that is Czech, all the people you've heard from today, but it actually gave us access to a whole bigger community. For instance, Shell helped us with our Hazid. They were very generous. Maersk were generous. DMV were generous. So we got this big community around us in addition to the people with Czech. And yes, we've got this vessel with 2 fantastic wings. It's probably the most photographed vessel last year. But now actually we have a Newcastle Max with 4 wings on. So 4 wings on a 300-metre plus vessel, which is a sight to behold. I was just on the phone to a Greek tanker owner, quite a difficult customer. I'm pretty sure they're going to order wind wings. So that's why I was a bit late. Sorry about that. But we're working with a UK tanker owner. We've announced 2 brand new build LR2s with 3 wings on each, and we will announce another 10 vessels in the next 2 months. So here we are, a small business. It's probably one of our 3 lines of business, but it's a really good trajectory for now, maybe even a medium-sized business, but, you know, we're going well, but definitely the seed was this grant. And I truly believe that grants are there for, you know, lots of different reasons, and decarbonisation is clearly one of them, but actually to get traction and impetus that we've done with WindWings, I'm particularly proud of, and I know Cargill are proud alongside us. So I'd like to thank all of the other consortium members, and particularly Carita and Suvi and all the administrators. So that's where we are as a business.